All right, folks, so in this section, we're going to be going over bar graphs. So graphs are used to display data. That's our general purpose of graphs. Bar graphs, segmented bar graphs, pie charts, pictographs are all appropriate types of graphs for displaying the data of categorical variables. So if we are talking about categorical instead of discrete, these are our options of graphs that we can use to display it. Bar graphs can also be used for discrete numerical variables. A bar graph displays the distribution of categorical value or variables showing the counts, which we call our frequency, for each category next to each other for easy comparison. So when we talked on the last page about how we can look at those percentages, we can picture those in our mind because we've had a lot of experience at this point using them. That's not normally true about the general public. Using a graph to display that and see them right beside each other with a concrete visual instead of picturing it in our mind, and our understanding of the percentage becomes a lot stronger for comparison. A bar graph consists of parallel bars with equal widths. An important piece here is that they have a space between each bar with lengths proportional to the frequency of the variables that they represent. So we know that we can build frequency tables and we can build relative frequency tables. If we are going to be working on these together, we're going to work on each of these pieces. Here we have a frequency table with US radio stations broken into the genres of the music that they broadcast. So we're being asked to complete the relative frequency column, this one right here, based on the frequency that we have for each of these. The first step we remember is that we need to have the number divided by the whole data set. So I'm going to take this 569 and I'm going to divide it by our 10,240. So that first piece right here, I'm going to go 569 divided by 10,240, and then I'll multiply that by 100% to get it written as a decimal. When I write that out as a decimal, I'm going to get 5.56 as my percentage. We can go through and do that for each of these. I encourage you to pause, take a minute, make sure you're comfortable calculating these. Remember, we need to make sure all of these ones add up to 100% at the end. So you should be able to take into account all the rounding that you're working on to get that accurately done. Assuming you've paused it, welcome back. Your number should be something like 8.49%, 20.18%, 21.28%, 8.85%, 25.15%, 6.11%, and 4.39%. And we total those up, we'll get a relative value of 100% for the frequency table there. Our second part of what we're going to try and do is take that relative frequency percent, because we know all these decimals, there's so many of these close together in the 20s, there's so many of these close together between 4 and 8. It's tough to see that actual distribution of the data. We'll throw these down onto graphs. We see that we have two of these shown here. This first one is looking at the frequency. This second one is the percentage of stations. So one of these is going to be the frequency, one of these is going to be the relative frequency. Make your guess on which is which. This will be graph number 1. This is graph number 2. So we'll pull out our rulers. We'll show a couple things on classic rock here. I'm going to go 556, remembering to make sure I leave a little space between each of my bars. My next one is 869. 869 for modern rock is probably going to be maybe a little bit higher than that, because that'd be 750. Sorry, my palm recognition is not recognizing. There we go. For modern rock. And then we have 2066 for country. For news talk, we have 2179. Then we have 900 for the oldies. For pop, we have 2,500, which is our highest category. Electronic is 626. 450 for hip hop and R&B. So then I'll take my ruler and I'll finish off all these bars. My digital writing tool snaps these out real nice. The expectation for any of this work that you're doing is it is drawn using a ruler every time. So what we've created here is a visual representation of the distribution of frequency for each of these stations. So when we had all these numbers up here, we could tell that there's a bit of a distribution of that. When I put them on a graph, I can actually see that a little bit more. These are the first three that I said were close together. Between 4 and 8 were these ones over here. Let's take our second graph and we're going to build it out over here. When you build it, or take a minute, pause and build it out yourself. You'll notice that when you do finish building it out, you're going to have the exact same spread and distribution of our data. So we know that on this axis, we had percentages. Each of our percentages, when we scale them appropriately, match here. So 500, 5%, and so on. Each of these show the exact same data. So what do we notice about all this information? The cool thing that we can notice is that the distribution, regardless of how we do this, is the same. Maybe a little bit of an exclamation mark on that one.